Hello. What we're going to do today is 8M1 Lesson 11, the efficacy of scientific notation. In other words, the power of scientific notation. So we're going to go over one of the first exercises in the lesson. Then I'm going to head on to another example that's like one in the lesson, and then I'm going to hit you with homework helpers. As always, feel free to fast forward to the end if you just are interested in the homework help. But if you're interested in some of the lesson and some of the another explanation about what goes on in the lesson, then feel free to listen to the whole thing. And let's just move right into it as quickly as we can. Okay, so this problem, exercise 1 and exercise 2, this is straight out of the classwork that you did in class today. And it encapsulates a lot of the learning that you've done so far. So, you know, the first thing that you have to do is you have to take these numbers and you need to convert them into scientific notation. And the key here is, you know, remembering. Well, there's a couple keys. So let's just do this one. Now, let's just look at first. Is this number bigger than 1, or is this number going to be less than 1? Well, let's think about that. Well, this is going to be less than 1 because this is 0.0000000. This is a very small number, very small number. This is very small. And so we know that because this number is very small, and in fact, the mass of an electron is very small as well, we know that because these numbers are less than 1, they are going to have a negative exponent. So when we convert these into some number like 2 times 10 to the something, this number up here is going to be negative. This is going to be negative. Okay, so I'll leave you to lessons 7, 8, 9, and 10 to understand exactly how to answer this if you don't know how to do it. But the answer is going to be, let me just give you the answer, is 1.672622, right? This number here, and it's times 10 to the negative 27th kilograms. Okay, right? It's going to be, and the answer, right, has to be this number here with a decimal after the first digit, and then it's how many times you move this decimal, which is going to be 27 times. Okay, and in this case, and there's further explanation of that in past lectures. So, and now if you do the same thing with an electron, you're going to say, well, let's go back to the original question. What's bigger, an electron or a proton? Which is bigger? And you can't really look at these numbers and know the answer. So that's why we're converting it into scientific notation, because one of the powers is our ability to easily compare numbers. That's one of the powers. Okay, so this answer is 9, and after you do this, it'll be 9.1093829 times 10 to the negative 31 kilograms. And now we have two numbers, a mass of the proton, right? This is our proton. And this is our electron. And because this number is much smaller, this is smaller, and it's smaller because negative 31, we're going to look at these guys right here, because negative 31 is less than negative 27. So this is smaller. So an electron is smaller. Electron is smaller. Electron has less mass. It's another way of saying it. Okay, so now we want to know about how many times smaller. Well, the way that you find that is you're just going to divide, right? If I know that basketballs weigh 10 pounds, basketballs, let's say, BBs, this would be basketball. Let me just spell it out to make it clear. So a basketball weighs 10 pounds, and a BB weighs, 0.001 pound. Then to figure out how many BBs I have to put in a bucket to weigh the same as a basketball, you just say, well, 10 divided by 0.001, or 10 over, and that's going to be, well, you can do the math on this, but it's going to be, I think, 10,000 is the answer. So 10,000 BBs would weigh the same as a basketball. You just simply divide it. So we're going to do the same thing here. How many protons, one proton, how many electrons weigh the same as a proton? So we're going to have to see how many electrons go into a proton. And if you do that division, and I have already kind of pre-done that here on, well, I actually haven't. I'm lying a little bit. So I'm going to do it for you. And the answer turns out to be about 1.8 times 10 to the third. And that kind of makes sense because this number here is about, if we just wanted to estimate it, let's just estimate this and let's see if this number makes sense. This is the number I got out of my calculator when I entered it. But let's see, if we're going to round this number, it's about 2 times 10 to the negative 27. If we divide that by 9 times 10 to the negative 31st, remember how we divide, we get 2 over 9 times 10 to the negative 27 over 10 to the negative 31st. And that's equal to 0.18 times 10 to the negative 10 to the fourth, or 1.8, because that's not in scientific notation. So it's 1.8 times 10 to the negative 1 times 10 to the fourth, or 1.8 times 10 to the third. So that works. Right? So one thing that, again, the key was we can easily compare numbers when we convert two things into scientific notation, and then we can divide them to see how many times bigger one is than the other. Okay, so let's just move on to the second problem that we have from our lesson. And so this is like example 5, or maybe it is example 5. And so we talk about, we're in this example, we're going to talk about the size of California. And we're going to do it in square miles. So the size of California is about 1.6 times 10 to the 5th square miles. And the size of the US is 3.8 times 10 to the 6th square miles. And so the question is how many Californias fit into one US? And I'm going to say, let's estimate. Let's estimate. I'm not here to do some hard, tricky division. Let's keep this simple and let's just estimate the answer. Okay, so if we estimate, we're going to say, well, first of all, what's the trick? Which one's bigger? Which one's bigger? I want you to think about that. And yeah, the US, this is bigger. So we're going to take the bigger one and divide it by the smaller one. 3.8 times 10 to the 6th over 1.6 times 10 to the 5th. And I told you it's okay to estimate. So let's just round this to one digit. So we're going to round this to 4.0 times 10 to the 6th. And on the bottom, we're going to call this 2.0 times 10 to the 5th. And now we can do this a little bit easier. And now remember, we got to go all the way back to lesson 7. But hopefully you're getting good at this now. You just divide, you divide your first two numbers and you get 2.0. And you subtract your exponents on the second one. So 6 minus 5. So 2 times 10 to the first is the same thing as 2 times 10, which is equal to 20. So there are about 20 Californias in the US. Okay. Good. All right. Now I'm going to move on to homework help. All of the problems really from this lesson are like, the homework is pretty much no different than just the problems from the day. So let's just look at some of these problems. I'm going to ask you some questions that hopefully are pretty straightforward to answer, but they'll get a little bit more difficult. So let's start off with this. I'm going to make up this problem, and I'm going to say I have a glass of water. And this is directly applicable to, this is homework help. And this one's like number 1 and number 2 on the problem set. So I have a glass of water, and it's going to have 7 times 10 to the 25th molecules of water. And then I'm going to take this from the problem. I'm going to say, well, 7 times 10 to the 27th atoms in my body. So my body, so we have a glass of water, and in this glass there are just lots of atoms. In fact, there's 7 times 10 to the 27th. And in Mr. Lipscomb's body, it's composed of 7 times 10 to the 27th atoms. So my first question is, which is bigger? Which is bigger? Which has more, particles? And atoms and molecules are both particles. So which has more particles? Well, if you think about it and pause. But the answer is, now hopefully you're back, you've thought about it, you've paused the video, you've thought about which one has more. And the key is this: you don't look at this number. You don't look at this number. You look at this number. And yes, so there are more, this is bigger. There are more atoms in my body than there are molecules of water in this glass. And so now the question is how many more times? So how many more times do you have to, how many more atoms do I have in my body than molecules is a multiplier. How many glasses of water would you have to put side by side before you'd have the same number of molecules that I have atoms in my body? And the way that we do that is division. Division. So we're going to take the bigger thing and divide it by the smaller thing. And voila, these are nice. 7 divided by, we're starting to get good at this. 7 divided by 7 is 1. And then to divide this portion, we take the 27 minus the 25 and we get 2. And we can convert this number back into regular numbers, and we get 100. So there's 100 times more atoms in my body than there are molecules in this glass of water that we concocted. So if we had 100 of these glasses of water, we'd have the same number of atoms that I had in my body. Okay, now I want to give you the last key, and this is going to really give you some help on homework help for number 3 and number 4. And this is in this case, we talk about population density. So let me just define that for you real quick. Population density. And that's going to be the number of people, and I'm going to put in brackets here and say on average, in a given area. Okay, so it doesn't mean the population density of, say, we're going to talk about the population density of a city called San Jose. So San Jose turns out to be a city, has about, and I rounded this, it's about 200 square miles. It's actually 180, but we're going to round it to 200 square miles. And inside, there are about 1 million people. 1 million people living in there. All right, and now in each square mile, so the question is, if we have 200 square miles inside here, and I'm not going to draw all the boxes, but each one of these is one of the 200 square miles. The question is how many people would be in each box? How many people would be in each box on average? On average. And the way that you did, how can we do that, right? How do we know? Well, let's just think about it. If we had like, if we had a box, if we had a really small area that had, say, 100 square feet, and inside we had 5 people, how many people on average would be inside? We have 500 people. How many people would be inside each square foot? Well, you'd have to have 5 inside each square foot, and then, because you'd have 500 people divided by 100 square feet, and you'd have 5 people per square foot. Okay, right? And another way to think about it is, once you have that density, just think about the words 5 people in each square foot. So in 2 square feet, you'd have 10. In 3 square feet, you'd have 15. And in 4, you'd have 20. So what you're doing for each square foot is you're multiplying by this density number. This is your population density. So in 100 square feet, you'd have 500 people. I don't know if that made sense. Okay. So over here, we have 1 million people. They have to be divided evenly among the 200 square miles. So we're going to take that 1 million people and divide it by 200. Well, that's kind of a hard thing to do. So I'm going to convert it into scientific notation, which is what we're doing in this chapter. And now it becomes a little bit easier, I think. A half times 10 to the fourth, right? We divide our first numbers, which is 0.5 times 10 to the fourth. Well, this isn't in scientific notation, recall, so we have to convert this into scientific notation. If you have another way to get from here to here, that's fine. I just like to do it this way. So the answer is 5 times 10 to the third, and that's our population density. And the units of that are people per square mile. Right? If we wanted to write that out, we'd write it out as 5,000 people. So in each square mile, we have 5,000 people, or 5 times 10 to the third people per square mile. Okay. Now we're going to ask one final question before I let you go, and that is, California, and we're going to use this answer here, so don't forget about it. California is 160,000 square miles. If California had the population density of San Jose, how many people would live in California? Now, this is kind of a ridiculous question because we know that California could never be as dense as the population of San Jose. If we just had, if California would be a big, jammed, full city, the entire state, if it was as dense as San Jose. We wouldn't have mountains with no one living in them. We wouldn't have lakes. We wouldn't have wilderness and all. And we wouldn't have super northern California where very few people live. So this is kind of a ridiculous question, but let's just pretend that California got so populated that it was as busy and crowded as San Jose. So how many people would live there? Well, if in 1 square mile, we're going to switch colors. In 1 square mile of San Jose, there are 5 times 10 to the third people. In each of these 160,000 square miles of California had 5,000 people in it. How many people would be in California? Well, we'd have 5 times 10 to the third people times the number of square miles. If 1 square mile has this many, then 160,000 square miles would have 160,000 times this number. Well, let's convert that into scientific notation. So we have 5 times 10 to the third. That's already in scientific notation. Times 1.6 times 10 to the fifth. And we get, for an answer, we get, well, 5 times 1.6 is 8.0. And 10 to the third times 10 to the fifth is 10 to the eighth. So that is a lot of people. And if you want to write it out, it would be 800,000,000. If the entire state of California was as dense as San Jose, we'd have 800 million people, which is more people in California than there are in the United States right now, which is 300. You know that that's really kind of an unrealistic number of people. It would be almost the number of people that there are in China, all just sitting inside California. So hopefully this is helpful. Hopefully this gives you some clues as to how to do your homework. Let me know. Please subscribe. Subscribe to this channel if you like it. I would encourage you. It helps me know that people are that you are watching. So if you this channel, that tells me you like it. Also hit the thumbs up like button on the videos. That will help me out, and feel free to leave a comment, ask questions about what's going on. And otherwise, I'll be back tomorrow with lesson 8 and 1, lesson 12. Thank you.